Hi friends, so in this new video I will talk about another important parameter that we use a lot of in microwave devices. This parameter we use a lot of in antennas, alright, antennas, filters, couplers. Okay, so this parameter is fidelity factor. What does mean fidelity factor? Okay, a lot of persons do not know what does mean fidelity factor. So this factor, this parameter, we can assume it's like a comparison between signals. Okay, like a comparison between two signals. Okay, so fidelity factor is a parameter used to quantify the distortion between two time signals. In different, when we talk about time signals, that means in two different time. Okay, so uh, fidelity factor. So if we assume that we have a system in general, we have a system. So we have input and we have output. So fidelity factor is a parameter that's compared between output and input. Okay. So fidelity factor we can assume it like efficiency in antennas. Okay. So it is a parameter that's compared between output and input in our system. Okay, so for fidelity factor we have two popular cases. Okay, two popular cases. The first case is the fidelity factor FF. Okay, we have the first case, popular case, we talk about fidelity factor FF, and the second popular case is system fidelity factor SFF. Okay, so in general we have two popular cases. The first is the fidelity factor FF, and the second case the system fidelity factor SFF. So in the next I will talk about these two cases, and I explain what does mean fidelity factor and system fidelity factor, and what does the difference between these two cases. Okay, so fidelity factor. So this parameter we use a lot of in antennas. So antennas are couplers or filters. Okay, so here for example in this figure one we have a transmitter antenna. So fidelity factor for antennas we use just for transmitter antennas. Okay, or horizon antennas, just in transmission. In emission. Okay, so fidelity factor we use it just in transmission side. Okay, so we have input power given by the source, and we have per radiated. So here the radiated power by antenna. So here fidelity factor compare between per radiated and per input in our transmitter antenna. Okay, fidelity factor is compared between per radiated and P input of our transmitter antenna. In reception antenna, we cannot talk about P radiated. We have P receive. Okay, P receive. So fidelity factor we use just for transmitter antenna. We compare between P inputs and P radiated by our antenna. Okay, so in conclusion, for this first case, fidelity factor, we can say that it is a comparison between P inputs and P radiated. Okay, P inputs and P radiated by our antenna. So this parameter it has been defined as the correlation between P inputs and P radiated. Okay, so theoretically how we can calculate this fidelity factor, so we can use correlation function. Okay, we work with correlation function between P inputs and P radiated. Okay, P inputs and P radiated. Okay, so the correlation function between P inputs and P radiated. Okay, so fidelity factor is a correlation between P input and P radiated for our transmitter antenna. Okay, if we have P input and we have P radiated, we can calculate the correlation between these two parameters and we can find the fidelity factor. So in general, if we have a fidelity factor superior or equal 0.9, we can talk about an acceptable fidelity factor, okay, for transmission. Okay, if we have a fidelity factor greater than 0.9, so we can say that it is unacceptable for pulse transmission. Okay, 0.9. The ideal case if we have one, okay, one. If we have one, so we can talk about ideal case. But in practically in measurement we cannot find one, so we can assume that if we have 0.9, so we can talk about an acceptable fidelity factor for transmission for this antenna. Okay. So now we go to the second case, system fidelity factor, SFF. So you say that we have system. So here we use this parameter SFF for a system. So we have antenna emission and antenna and reception. Okay, so in figure 2 we have transmitter and receiver antennas. Not like the first case we have just the transmitter antenna. So in this example we have two antennas, one in emission and one in reception. So here system fidelity factor, it is a comparison between P received, okay, P received by the receiver antenna, okay, and P input in our transmitter antenna. So it is a comparison, it is a correlation between P input of our transmitter antenna and P received by our receiver antenna. Okay, we can talk about system fidelity factor between P input of our transmitter antenna and P received by our receiver antenna. Okay, so here if we see a lot of people published in journals, okay, we can see that a lot of persons study this parameter in function of angles. Okay, so for example for the first case I take reception. So here we talk about antenna and reception at phi equal 0 degree, and second case for phi equal 13 degrees, and third case for 14 degrees, and like that. Okay, so for multiple angles. Okay, so we can start the system fidelity factor SFF for multiple angles. It is a comparison between the main beam, okay, main direction and other direction, other angles. Okay, so between the transmitter antenna and receiver antenna. Okay, so here we can conclude this second part by this schematic. Okay, so system fidelity factor SFF, it is a comparison between P input of our transmitter antenna and P received by the receiver antenna. Okay, so it is a correlation between P input in transmitter antenna and P received by our receiver antenna. Okay, so when we say P input, does mean the power delivered by source, the power delivered by the source toward our antenna. It is P input. Okay, so this system fidelity factor, it is a correlation between P input and P received, power received by our receiver antenna. Okay, so in this video I talked about the definition of fidelity factor and system fidelity factors. Okay, these two popular cases. So in the next videos I will put example of simulation. Okay, for example for in HFSS or CST I want to compare between P radiated and be input, I can import or export them from HFSS, and I work by coefficient correlation in MATLAB. Okay, I import these two parameters to MATLAB and I compile, I calculate the correlation of this antenna. Okay, so in the next video I will put simulation, an example of simulation for this example. Okay, so if you have any question, any remark, you can contact me by comments in video or in our page Facebook. Okay, so see you soon in other video.